Hi everyone. So in this video also we are going to continue the paging concepts. So in this video we are going to discuss that what is page replacement algorithm. So there are five major algorithms that are available. So but in this video we are going to discuss only three in detail. Okay. So first one is a first in first out page replacement algorithm, and second one is a least recently used page replacement algorithm, and third one is the optimal page replacement algorithm. So other two algorithms are second chance algorithm, enhanced second chance algorithm. But those two algorithms we are not going to discuss in this video. So we are going to discuss these three algorithms also. So here I have mentioned that already I have mentioned that you people may know that what is paging, then what is page replacement, right? What is the meaning of page hit and page fault, all these things, right? Here I'm just going to concentrate only the page replacement algorithms, right? Okay. So I have mentioned that my frame size is 3, right? So this is my frame size, right? So frame size is 3 here, right? So first in first out means, so this is the sequence, right? Okay, so here you can see that this is the number of pages required for a particular process to complete, right? Okay, so every time the process execution, operating system will verify that whether the required page is there or not in the frame. But if the required page is not there in the frame, automatically that is called page fault, right? If the required page is there in the frame, that is called page hit. Right, now here initially the frame is empty, so initially there are 3 page fault will occur. So how the 3 page fault will occur? For page number 7, first page fault will occur. For page number 0, the second page fault will occur. For page number 1, the third page fault will occur. Right, okay. So based on this, automatically the 3 first, this is first come first serve, right? So this one is 1 and 2 and 3, 4, like that it's coming. So one by one the page is entering into the frame. Right, now, so 3, now the whole frame is completed. There is no space for new page to entry. Right, so now the required page is here. This one, 2 is required, but here there is no space in the frame. But now what I need to do, I need to go for a replacement. So I need to find out the victim page, right? I need to find out the victim page. So victim page means I am just using my operating system using the first in first out algorithm. So first in first out algorithm means which page came into the frame first, that page will be replaced here, right? Okay, so here you can see that, so here the order, the 7 came first, 0 came second, and here 1 came in the third position, right? Now which one is the victim page? Now page number 7 is the victim page, so this need to be replaced for newer page, right? Okay, so here the newer, now for page number 2 also the page fault will occur, right? For page number 2, because the required page is not there in the frame, so page fault will occur. So for this page number 2, the 7 will be the victim page. So instead of 7, so the 2 will be entered here, and remaining are same. So here 0 and 1. Right, now the entry is over. Okay, so now here, what is the next sequence? So next sequence, if you are checking, and this will be the 5 in coming in the sequence is 5. So 0 is required. So 0 will be verified here in the frame, right? This is the new frame here, new sequence. So 0 is already there, right? No, okay. So here page hit happens, because required page is there in the frame. So page hit happens, right? Now what is the next page required? So next page required is 3. So whether the operating system verifies that the page number 3 is there or not? No. For page number 3, again page fault will happen. So if the page fault happens, you need to go for a process, that is you need to identify the victim page. So which one is the victim page? Now here. So based on this entry, so here the page number 2 came to the position 2 and 3, and this one came to the 4th position. Right, okay. So now this order need to be verified. So which one came first now? Here, this will be the victim page. So page number 0 will be the victim page according to the order entered into the frame. Right. So now instead of 0, now your new page will be entered here. Fine. Okay. So now here already 2 is there, then 1 is there. Instead of 0, you need to enter 3. Okay, so now you can able to understand what is the process for first in first out algorithm, first in first out page replacement algorithm. So in least recently used algorithm, right? Okay, the previous one we have seen that is first in first out. Now we are going to discuss that least recently used algorithm. So in this again the same order, the same page sequence I have taken. So again first initially 3 page faults will occur. So for 7 1 page fault, for 0 another page fault, for 1 also page fault, right? Now the whole frame, the whole number of frames are filled by the page. So now the new page entry is 2. So page number 2 need to be entered. So now here, according to the FIFO, the first page came inside, that page will be the victim page, but here it's completely different, right? Okay. The understanding is least recently used. You need to understand that which are, so up to now, how many pages are used? In the number of pages used, which one is least recently used? Right? Okay. So now here, so we can give the rank order. So which one recently used? Huh? The higher number will be the recently used, and the lower number will be the least recently used. Here you can see that number 7 came first, so that will be the rank number 1. And here this is the rank number 2 and 3. So according to this order, you can see that which one will be the recently used. So page number 3 will be the recently used, because the last page fault occurred as 1. So for that the 1 came, so this will be the recently used. So before that 0 came, and before that 7. So now again here also page number 7 will be the victim page. Instead of 7 you can put the newer entry. So newer page will be entered here. So instead of 7 the 2 is coming here, 0 and here 1. Right? Now based on this entry the order will be changed. Right? Now least recently used means here the order automatically changes. So this one will be the 1. And this one will be the 2 and this one will be the 3. Right? You are able to understand. Now this one will be the newer page, least recently used page. And this one will be the least recently, very before used, right? So now again the another request. So request is 0. Now understand that here required page is 0. So the operating system verifies that whether the required page is there or not. Yes, the required page is there in the frame, automatically page hit happens. Right. Now you need to understand that here automatically because of this page hit the reference will be changed. So reference is what here. So this will be the 3 and this becomes 1 and this becomes 2. Able to understand now? So now the whole order has been changed. Right. So now this will be the 1 and 2 and 0. 0, because in the previous FIFO, this will be the order 2. Anyway, if the second page you want to replace, 0 you need to replace. But here it's completely different, because now the order, the recently used order has been changed here. So now here for the order has been changed, 0. Right. If again, so now you just see that 3 is required. 3 is the required. So now you need to see this order, which one need to be used. Right. Recently used is 0, because that's the highest number, recently used. Least recently used means that's the 1. So 1, 2, 3. So 1 will be replaced, 1 will be the victim page, and here 2, 0, and instead of 1, the 3 will be entered. Now here, this 3 will become the recent, and this becomes 2, and this becomes 1. Right? Able to understand what is the difference between first come first serve and here least recently used algorithm. So now what we are going to see it. So we are going to see that optimal page replacement. Okay. So now for this optimal page replacement algorithm also, so initially 3 page faults will happen, because all 3 frames are empty. So for 7, 1 page fault, for 0, 1 page fault, for 1 page fault. So 3 page fault will come. So automatically the 3 frames will be filled. So now the newer page, again the newer page is 2. Right. So here you need to understand that up to FIFO and LRU, the number of pages used will be verified. But here in optimal page replacement, it will verify the whole sequence, right? Remaining, how many pages are remain to be entered. Right. Now for the page number 2, there must be, you need to find out that which one will be the victim page. So here you need to see that here 7, 0, 1. So in the coming sequence, you need to understand here, in coming sequence, where or when this particular page is required, right? So you need to understand that where 7 is coming, here 7 is coming here, right? Okay, after that where 0 is coming, 0 immediately it's coming, and again here also 0 is there, and 1 where 1 is required, and here, right? Now you just see that which one is not required for very longer period of time. So see that 0 is required recently, very quickly, and then 1 is also required, but 7, if you're checking 7 will be the longest period of time, it's not required. So again here in this algorithm also, 7 will be the victim page. But only you need to understand that why again I'm picking 7 now. So in this, based on this sequence alone, in this sequence 7 will be the, it's not required for longest period of time. So 7 will be the victim page. So now here instead of 7, 2 will be there, 0, then 1. Right? For the next one, right? Next sequence is what? 0. So 0 is required. So page hit happens here. Again, page hit happens. And the next required is what? So next required is 3. So 3, you need to understand that which one. Again, you need to find out the victim page. For page number 3, you need to identify. So say, see that where 2 is required. So 2 is required here. Where 0 is required, immediately 0 is required. Then where 1 is required, it verifies that. So 1 will be the very longest period. So 1 may not required for very longest period. So 1 will fall in the victim page. Right? Okay. So 1 will be the victim page. So 2, 0, and 3. Right? Now this is the current sequence. But what is the next requirement here? So 3 has been entered. So again 0 is required. So 0 is referred. So here no need to worry about the reference, when it is used, when it is not used very longer period of time. Not this one may not concentrating on the used pages. This will concentrate on the coming sequence of pages. Okay. So here again for 2 and 0 and 3. So now, so 2 is utilized. Then for 4 you need to find out the victim page. So again 2 you need to verify immediately, it may be required. 0 it may be required. Then 3. Now see that here 1, 2, 3. You need to put it that in the sequence. Immediately next by next the sequence is there. So which one is in this sequence? Which one may not be required for a longer period of time? 2 is required immediately. 3 also next immediate. Then 0 may not be required for longer period of time in the sequence. In this 3 alone. In this 3 alone, I am saying. Right. So now which one will be the victim page? Now 0 will become the victim page. So here 2, then 4, 3. Right? So this is how you can understand that what is first in first out page replacement algorithm, then least recently used page replacement algorithm, then last one is the optimal page replacement algorithm. Thank you.